right, so our next speaker is Travis Rainey. Travis is a master's student at Central Michigan University, just finishing up almost, right, Travis? During his undergrad in his hometown of Cleveland, Ohio, he became interested in conservation biology. He heard of and began reading about the chytrid pandemic. There seems to be a little bit of a trend here this morning. This propagated his interest in amphibians whose life histories and resilience already fascinated him. While spending a few years bounding around the country working technician jobs, he landed a herpetological position in Wyoming that solidified this interest. He hopes to help answer questions that can better inform how to protect vulnerable species and to advocate for such protections. And I also want to put a little plug in for Travis. Travis was one of our research fellows last year at the Institute. And so we've gotten to know Travis fairly well, I feel, over the last year or so, and are really excited to see some of his research findings. All right, so I'm going to end this poll here. Hopefully everyone got a chance to answer. I'm going to end it in 5, 4, 3, 2, and 1. All right, and so it looks like most people have heard of Blanchard's cricket frog, so 85%. Did you know Blanchard cricket frog is regionally threatened? Well, 72% said yes, so yay, that's 3/4 almost. Would you be confident in your ability to identify it by sight? We're about 50-50 on this one. 57% said no. And would you be confident in your ability to identify it by sound? More thought they could identify it by sound, or excuse me, less thought they could identify it by sound. I said it opposite. 37% thought they could only identify it by sound. And on Facebook, we got no for identifying by sight, but yes by sound. So it shows us we have a little more to, oops, I forgot to share those results. There you go. A little bit more to go and to learn, right, Travis?
Yeah.
All right, so I'm going to stop sharing that and I'm going to hand it off to you. And I'm very excited to learn about Blanchard's cricket frog.
Thanks, Ellen. And thanks everybody for being here. If you don't know what they look like, here's just a nice watercolor that field technician Emily Trace did and gave to me of the species. But again, my name's Travis Rainey, and I am finishing up my master's at Central Michigan University. And today I'm going to be talking about the Blanchard's cricket frog and some of the obstacles that it's facing, particularly here in Michigan. Oops, let me, now just some background on the species. It's wide ranging. As you can see here on this range map depicted in the dark gray, that's the Blanchard's cricket frog range. They were first described in 2008, and previously they had been considered a subspecies of Acris crepitans, the northern cricket frog, depicted on the range map in the lighter gray. And there are some regional conservation concerns for the species. It was once one of the most common and abundant frogs across most of its range, but it's been well documented that northern populations have been declining since at least the 1970s. And so many states, including Michigan, have Blanchard's cricket frog on their threatened and endangered species lists. Here in Michigan, they're considered threatened. There's been lots of research on the species, but ultimately the magnitude of these observed declines remains unaccounted for. So we're not really sure exactly why this is going on. Southern populations are not experiencing these declines, it's thought, like you can see in places like Oklahoma and Texas. So one might think, you know, why does it matter that these northern populations are declining if the species is doing just fine elsewhere? Well, I'll tell you why. A lot of literature suggests that climate warming is expected to skew many species' suitable habitat towards the poles. So in our case, being in the northern hemisphere, you know, towards the north. And here, just quickly, I wanted to show, so this map depicts some climate niche modeling that I did, depicting the undercurrent climate conditions. So the darker red depicts like the most suitable climate for the species currently, which you can see is in the central and southern range. But then in the coming decades, this will drastically shift northward under both high greenhouse gas emission scenarios. So if you can see my cursor, this top map I'm sorry, the bottom map under high greenhouse gas emissions, and then under even low greenhouse gas emissions predictions in the year 2100, there's a lot of that suitable habitat in the central and southern range is going to probably not be there. And so in other words, the central and southern populations might be in trouble in coming years. Now it's just some natural history on the species. They can be found in all kinds of water bodies, streams, both permanent and ephemeral water bodies, but they're known to mostly prefer like muddy edges of water features, which they prefer open, like places that are not dense with vegetation, as you can see here, like in this picture of this amplexing pair, in kind of like a mud flat area. And here's just some more pictures of some typical microhabitat. Here's one in some sparse grass and a bunch of duckweed. And then these guys, I like this picture. It's two males perched up in this willow. I think it's kind of cool. They're relatively small and they are sexually dimorphic, whereby females are larger. Here's just a distribution of mass and snout vent length, which is just a proxy for body length here. And the box and whiskers on the right of each graph show that females are larger in both mass and length. And of about 800 cricket frogs we caught last year, the biggest one was a whopping 3.13 grams. So it's pretty tiny. Their breeding season and overwintering phenology depends on their geography, obviously, but here in Michigan, they generally start calling in mid-May and they go through July. And they're active foraging and such through the fall until overwintering begins. And they face a lot of challenges in terms of overwintering. They cannot alter their glucose concentrations in their tissues, similar to wood frogs or other types of tree frogs, if you're familiar with that process of creating what is commonly referred to as antifreeze. They also do not actively burrow, so they rely on other animals' burrows like crayfish and such, or abiotic factors like cracks in stream banks in order to find little nooks and crannies to hopefully make it through the winter. So all these factors mean that there's a high mortality over winter. So it's thought that in a lot of cases, most of the cricket frogs don't actually make it through to the spring. And some natural history notes important for the work I'm talking about today. They have limited dispersal ability, so they're thought to stay close to their breeding grounds. And a behavioral study shows that Blanchard's cricket frogs show an aversion to entering forests, so they don't like to migrate through forests, but they do seem to show a readiness to enter agricultural landscapes. Also, they're an annual species, meaning that especially in the northern range, they probably won't live through 2 breeding seasons. So in other words, if they're lucky enough to make it through to the spring, that's probably their one shot at reproducing, is that 1 year. They probably won't make it. Here's just a quick video of the first one I ever caught that shows how small they are. It happened to be tripedal. I don't know what caused that, and I'm trying to search for some cosmic meaning as to why the first one I ever caught only had 3 legs. And here's just a quick video of their call. So for those of you who aren't familiar, this is what they sound like. Okay. And here, so I'm going to be talking about some 2 main objectives. The first being to determine the degree of local extinction that has occurred across the historic Michigan range. This could be important. It's an important management objective to first just inventory what's left, and is there even a problem? Maybe. Umbrellaed under that objective, I also wanted to look at signs of local extinction events occurring in the past few decades, especially because there's some suggestion that they're rebounding in other states. I also wanted to aim to explore the relationship between the landscape and persistence. And so if there does appear to be a relationship, what landscape metrics drive the difference or the relationship that's observed, and at what spatial scale can this relationship be observed at? So for this first objective, to determine the magnitude of Michigan declines, I first gathered all the historical records I could find, most of which came from Michigan Natural Features Inventory, so big thanks to them. I also got a couple additional records from citizen science sources like iNaturalist. In total, I got 118 unique historical sites outlined here on this map in the yellow and green. Then I conducted call surveys at all these blue and red dots on the map surrounding these historical sites. And in case you're not familiar, call surveys are just kind of like a passive way to detect the presence of critters that make noise. And as I showed, the males during the breeding season will make that call. So you don't actually have to go out and find them. And trust me, that can be harder than it seems to find these little camouflage frogs. And so I conducted 499 of these call surveys. And the reason I had so many more call surveys than I did historic sites is because I attempted to revisit sites multiple times, and many of the sites were pretty big, so that required multiple survey locations. To be considered surveyed, a historic site needed to be at least 400 meters. I needed to have a survey within 400 meters of the site's boundary, which was the estimated distance I thought I could hear a chorus of males. And to be considered extant, meaning that the species still exists there, I had to have some kind of detection within 1.3 kilometers of its boundary, which is the estimated maximum dispersal event ever recorded for the species. Statistically speaking, for this first objective, it's pretty basic. I just isolated historic sites by the year of their last recorded observation. In other words, the most recent date that we know that Blanchard's cricket frogs were at a location, and then I just simply calculate a proportion of the X. For objective 2, to look at the relationship between the landscape and persistence, I started with those survey points. Then I created buffers around each of these survey locations at 4 different scales. So I made a radius of these different length or distances. Each of these distances represents some kind of ecologically significant distance from my literature review, which I can explain in the discussion if anyone's interested. Then in a geographic information systems mapping application, I added current land cover data. In my case, this is a free version offered from the US Geological Survey, which is depicted here on the map, these pixelated, color-coded. The colors represent some kind of different land cover type. And then I calculated the proportions of each of these land cover types within those buffers. Then, which was my composition component. Then I quantified the number of patches or areas of like land cover types within each buffer for a proxy for configuration, whereby higher patch density means a more heterogeneous landscape, and a lower patch density would mean a more homogeneous landscape. And so if you're following my cursor, like this area here that I'm circling would be more homogeneous relative to this area over here, because this area over here, as you can see, has like a lot more patches. Then I added a stream layer to the map to quantify the density of streams. So in other words, the length of streams within the buffer. And I did this as a proxy for connectivity between sites, because cricket frogs are known to use streams as migratory corridors to get between wetlands. And so the stats for this landscape component, I'm not going to go into too much detail with it, but the important thing is that my data did not meet multivariate normality, even after attempting a plethora of transformations. And so to test for the overall differences, including all those landscape metrics, I used multivariate statistical approaches, including multiple response permutation procedure and non-metric multi-dimensional scaling. Then to look at specific landscape metrics and how they differ between extant and extirpated sites, I used Wilcoxon rank sum test with Bonferroni corrections. So finally, for the results, for the first objective to determine the magnitude of Michigan declines, working alone on a tight budget, I was able to survey 111 of those 118 historic sites. And as expected, I found a high degree of overall extirpation being local extinction. Considering all historic sites, which dated back to 1900, just 32% of those remain extant. And I also found evidence for recent extirpations. So in other words, like in the last 20 years or so, as 32% of sites where Blanchard's cricket frogs have been observed in or after 2000 appear extirpated. Even looking at sites where Blanchard's cricket frogs have been observed in or after 2010, it seems that potentially 9% of those sites are extirpated. I should note the caveat that there could be the potential for false absences here, whereby like the frogs could have been there, but I just didn't hear them. But as I said, I did try to revisit sites and I had multiple survey locations at sites, so I'm pretty confident that I would have detected them had they been at those locations. Okay. For objective 2, determining the relationship between landscape and the persistence. For my MRPP analysis, the landscapes within buffers of extirpated and extant sites significantly differed at all spatial scales. However, there was some ambiguity for separation between extant and extirpated sites using the NMDS. And I don't have a whole lot I can't explain the nuances of this, and this graph depicts a whole lot of information that I'm not going to get into, but what I want to highlight here. So this is an NMDS graph for the smallest spatial scale, the 300-meter scale. And I want to highlight, if you're following my cursor, these ellipses here for the centroids. Basically, this is like the multi-dimensional or multivariate space for the extant sites. And as you can see, it doesn't overlap with the extirpated sites. However, now I'm going to click it to the largest spatial scale. There is some overlap, which could suggest that there's not as clear a separation between extant and extirpated sites at those larger spatial scales. But I think more importantly, what I want to get into is looking at the specific landscape metrics. And so I had these 10 landscape variables, 5 of which significantly differed between extirpated and extant sites at least one spatial scale. So those ones that here are outlined in the beige, and these ones seem to explain the differences that were observed in the multivariate space. And these highlighted in gray, I did not find any significant differences at any spatial scales. So the proportion of woody wetlands, the proportion of barren land, the proportion of open water, patch density, the number of patches per hectare, and stream density, I did not find significant differences. Starting with the ones I did find differences for, the proportion of developed land, which is characterized by urban pavement, impervious surfaces. This was higher surrounding extirpated sites, as you can see here on this box and whisker plot at the 300-meter radius. So for the box on the left, this shows the proportion of developed land cover surrounding extirpated sites. The box and whisker on the left or on the right here shows the proportion of developed land surrounding extant sites. And the next series of graphs I'm going to show are going to follow this same pattern or the same format. I also found a significant difference at the 600-meter scale. And this relationship, this negative influence of development is intuitive, as habitat loss is the main perpetrator in amphibian declines globally, maybe seconded by the chytrid fungus we've been talking about today. And likely the most direct cause of habitat loss is the development of roads and residential areas and such that leads to this category, this developed category. Also significantly higher in proportion, I found forest cover to be higher surrounding extirpated sites only at the smallest spatial scale for this, which may seem counterintuitive as we might associate forests with a positive influence on wildlife. But as I stated earlier, Blanchard's cricket frogs are known to prefer more open canopy, and they do not like to permeate into forested areas. Being that this difference is only found at the smallest spatial scale, it shows that there might be an importance for the immediate area surrounding breeding ponds to be free of dense tree cover. And possibly fire suppression has acted against cricket frogs in this way, but it's speculative. Okay, now looking at shrubby herbaceous cover, this was more prevalent around the extant sites. So I'm highlighting these. The red ones had a negative relationship with persistence, and the ones that I'm going to highlight in blue, the rest of these here are going to have a positive influence on persistence. Shrubby herbaceous cover was more prevalent surrounding the extant sites. But as you can see on the y-axis here, overall, this type of land cover accounted for a very small amount of the total landscape, and even at the highest, it's only about 4% of one of these 300-meter buffers. And this makes sense because it's a shrubby herbaceous would be an open canopy. Now, this also seem counter to typical land use wildlife associations, but agricultural land accounted for a greater proportion of the landscape surrounding extant sites. So this places where Blanchard's cricket frogs still are at both the 300, 600, and the 1300 meter scales. I found this pretty interesting, and it poses more questions that I don't necessarily have the answers for, like, does agricultural land substitute, as a way to open up the canopy and in an absence of historic fire regimes? Is it just a catalyst for opening the canopy? And what about all the known hindrances that herbicides and other agrochemicals have on Blanchard's cricket frogs or amphibians that we know about? Because we typically think of agriculture as like a bad thing. Being that this difference is observed at even the second largest scale suggests to me that agricultural land might facilitate dispersal events, allowing for movement between wetlands, which kind of matches that behavioral study that I mentioned that showed that they're willing to enter agricultural landscapes. I also have found that emergent wetlands were more prevalent surrounding extant sites at the smallest spatial scale, which also fits that open canopy. So a lot to consider, but I'm still in the process of trying to figure out what this all means, and maybe it just poses more questions than answers. But anyway, here we're just going to blow through this. So if you want to check my references, you'll have to maybe see the YouTube video and pause it. But just I wanted to share a quick little story that I think is hopeful. So if you can see my cursor here, this top red dot here was a site where Blanchard's cricket frogs were translocated to about 20 years ago, 15, 20 years ago. It's still booming today. It's a very healthy population, it seems. But what I think is really cool is that I detected the species down here at this southern red dot. And as far as anyone knows, these frogs weren't anywhere near this area at any point. So reason would have it that they were able to migrate and colonize this little place down here. And this is about 5 river miles or so. I redacted all the identifying information just to protect, because they're a protected species. I didn't want to get in trouble. But I do want to share that because it seems pretty exciting to me. And I have some genetic samples that hopefully will confirm that this southern spot down here did in fact come from the northern spot. Also, I just want to say briefly, I was invited to join this working group on the species, and we're in the process of organizing a BioBlitz this summer for Blanchard's cricket frogs, whereby we're looking for help to look for them, especially in data deficient areas. So if you're interested in helping out, email me and I'll send you the information as it comes about. Otherwise, I want to thank you for your time. And I want to have a special thanks to this list of institutions and folks. Here's my email if you want to email me. And if there's still time remaining, I'll be happy to answer any questions you have.
We do have some questions. The first question, I had the same question. Have you used Herp Mapper at all to collect or use citizen science data? So like the Herp Atlas, Herp Mapper, anything like that?
Yeah, there's I tried to source data from all different places originally, and a lot of it was overlapping. So like for instance, there'd be like many observations at one site, and so when I defined those historic sites, I made sure that they were at least 1.3 kilometers apart in order to be considered a unique site, since I couldn't really justify calling a place that's only a couple hundred meters apart a unique site. But yeah, I tried to, unfortunately, there weren't, like on iNaturalist, there's maybe a dozen or 2 dozen observations in the whole state, at least at the time, for Blanchard's cricket frog. So that's why we should all go out this summer and try to find
Join your BioBlitz, right?
Yeah.
What you're telling us. I like that. That's a good take home. Another question we have is, Travis, do you have any insight into the effect of narrow-leaf cattail and Phragmites colonization of wetlands on the Blanchard cricket frog persistence or habitat quality? So some of these common invasives that we have here in Michigan and surrounding areas.
Yeah, that's a great question. I don't have any like empirical evidence for that, but I can say that surprisingly, like there were quite a few sites. I went to about 40, 50 sites last summer to collect genetic samples, and there were quite a few that I was surprised how dense the cattails and Phragmites were. But it seemed like at those sites, the kind of the microhabitats that the Blanchard's cricket frog would be found at and seem to hang out at and chorus in and stuff were the kind of the more open edges. So they can seem to still persist at places that have cattails and Phragmites and such, but if they're completely inundated with those emergent plant species, that that could, I think, probably hinder their persistence.
Yeah, makes sense, unfortunately. Another question we had, given the quick life cycle of these frogs, does that imply management techniques should result in a quick response from the frogs? Hopefully. That's
a good question too. Yeah, I hope so, because the quicker you can find out if what you're doing is working, the better. But yeah, looking at genetic variation, which is something that I'm interested in now, I would hope that some of the things that we typically don't see happening until longer stretches of time, that it would be expedited because of their annual life history. And so, yeah, I think that's a good question. I haven't thought about that too much, but I would think that hopefully they respond to management decisions more quickly, and that would be an exciting thing to see. And similarly, like that colonization event, that 5 or 6 river miles seems to me to be a pretty far distance for something that weighs 2 grams or whatever. And they were able to do that, and there seems to be like they were able to do that, in 10, 15 years. So that's pretty cool.
Yeah. I have one other question that came through in the chat. Are there other frogs in Michigan that are annual like these? Did you know that, Travis, at all?
That's a good question. My hunch is that most are longer living, but I can't speak with 100% confidence on that. I know that like green frogs and bullfrogs, the other common species, they live multiple years, and even their larvae can defer metamorphosis for multiple years. And so I think they're probably the shortest living, but I can't say that with confidence. A quick search, I guess I could answer that.
Or I know we have a lot of great knowledge in whoever's joining us today, all our participants. So if anybody wants to answer that question in the chat, we would appreciate it as well. So I have one other question, kind of taking it home for us. What would you recommend, and this is very tentative, lots of caveats included, what would you recommend to landowners or land managers that want to attract cricket frogs? What would you recommend to them in things to do or management practices that you might encourage that might attract these frogs?
Yeah, that's a good question too. I think similar to the question about Phragmites and cattails and such, I think, trying to clear dense vegetation like that, especially the invasive stuff, might help. In terms of attracting them, that's a tough question, because colonization events are pretty rare, and so that's a whole nother story. But in terms of making a nice home for cricket frogs, I think, yeah, having some clear edge, terrestrial aquatic edge, that's probably important, and like mud flats and stuff that they prefer.
So if you have further questions for Travis, you think of them later, feel free to, I'm going to say feel free to email him because I'm pretty sure he'll try to answer them. Thank you so much, Travis. This was so informative.
Thanks for the opportunity.
All right.